All right, so we have one more skill we want to be able to do, and that's to balance redox reactions in aqueous media. So this is more complex than balancing your standard reactions. And the reason that it's more complex is that this occurs in water. And this water can actually interact with the reaction, right? So this water can act as a reactant or a product. And whether we're in acidic media, so we have a bunch of H plus flying around, or basic, where we have more hydroxide, that's also going to change the way that we balance them. So let's start off with acidic components, right? So we're going to balance a redox reaction in acidic aqueous solutions, right? So we're aqueous, so we have water, and then we're acidic, so we have H plus as well to add to our reactions. So here's kind of the steps listed 1 through 7, although there is a step 0 that they didn't include here, but that's fine. Step 0 here is going to be to split the reaction into 2 half cells based on whether they're being oxidized or reduced. So let's go ahead and take an example, and this will make a lot more sense as we go through our example. So let's take a look at this one. This is dichromate reacting with iron 2 plus to form chromium 3 plus and iron 3 plus. And so when you're first looking at this reaction and trying to balance it, one of the things you may notice is that we have oxygens on this side, but no oxygens on the other side. Right? So if you try to balance this based on how you learned in Chem 101, it's not going to be possible. We don't have oxygens on either side or on both sides. So we can't balance it. And so what this means is that this water is coming from, or these oxygens are coming from the water from the reaction. So anyways, we're at step 0, and that's to split into 2 reactions. Right, so we're going to split into our redox half cell reactions, right? So on one side, we can note that we have this chromium, and then we have this chromium here, right? So that's going to be one side of our equation. And then the other half of the other half cell is going to be with the iron. And then we can label both sides. This step isn't necessary, but it's good to know. If you think about the oxidation state of this chromium, I'm not going to go over it too hard, but this oxidation state is +7. Over here, we obviously have +3. So going from +7 to +3, this is the reduction half cell. And then obviously here, we're going from +2 to +3. So that's the oxidation half cell. Cool. So that was our first step. Split this up into 2 half cell reactions. Then the next step, we're going to want to balance elements in the equation other than oxygen or hydrogens. So balance non-oxygen/hydrogen elements. And I'm just going to go ahead and rewrite this equation. I'm going to rewrite this equation a lot. You don't have to when you're doing these problems. I'm just doing it just to make sure that I'm being super clear what's occurring in each step. But once you get pretty good at it, you do not have to keep rewriting these. So we're not going to take a look at the oxygens or the hydrogens. On this left side here, we see that we have 2 chromiums, and here we only have 1 chromium. So we have to balance that out by putting a 2 on the chromium on the right side. On this other half cell, we have 1 iron and 1 iron on either side, so we don't have to balance there. We're not paying attention to charge yet, just the identity of the elements. Then step 2 here is balance the oxygen atoms by adding the appropriate number of waters. Again, I'm going to rewrite this. You don't have to rewrite this so many times, but it's good at the start. So in this case, we notice that we have 7 oxygens on this side. So to balance that out, we need to add 7 waters. On the right side here, we don't have any oxygens, so we don't have to worry about that. Then we go on to our next step. We want to balance the hydrogen atoms and including those from the water by adding H pluses. Again, I'm going to rewrite it. You don't have to rewrite it so many times. So over here, we notice that we have seven waters, which each have 2 hydrogens. So that's 14 hydrogens. So we have to put 14 H pluses on the left side. Over here, we have no hydrogen, so we don't have to worry about balancing that. Step 4, we have to balance the charges by adding electrons. Again, I'm going to rewrite the equation. You don't have to rewrite it this many times. But I just want to be clear about what's going on in each step. All right, so let's go ahead and take a look at our charges. If we think about this chromium, that's a 2- right there. If we think about these 14 H pluses, that's a plus 14 right there. And so then if we add these up, we get plus 12 on this side. Over here, we have 2 times plus 3. And then this one over here is 0. So over here, we have a plus 6. So to balance that out, we need to add 6 electrons to the left side, right? Because electrons are negative, so they'll cancel out 6 of these, and then we'll get 6 is equal to 6. Be careful which side you put the electrons on. This is probably one of the most common mistakes. Over here, we have plus 2. Over here, we have plus 3. So to balance that out, we have to add 1 electron to the right side. And note that your electron should always be added on the opposite sides. And what I mean by that is over here, we're added to the reactant side. Over here, we added to the product side. If you add them both to the reactant or both to the product side, you did something wrong. Cool, so that's done. Next step is the electrons must be equal on the same side, so multiply to make them equal. So we'll call that make the number of electrons equal in both reactions. So here we have 6 electrons plus this dichromate plus 14 H pluses goes to Cr3 pluses and then 7 waters. Whereas on this other side, we have an Fe2 plus going into an Fe3 plus and 1 electron. So we have to make the electrons the same on either side. Here we have 6. Here we have 1. So to make them the same, we have to multiply our right equation times 6. So this becomes 6 Fe2 plus 6 Fe3 plus 6 electrons, right? So we have to multiply the whole equation by 6. In this case, we just had to multiply one side. That's not always going to be true. So just for like a hypothetical, if one side had 2 electrons and then the other side had 3 electrons, you'd have to find the lowest common denominator or lowest common multiple. So you would multiply this side by 3 and this side by 2 to get 6. In this case, we didn't have to worry about that because we just had to multiply one side. Step 6 is the half reactions are added together and then canceling out the electrons and form one balanced equation, right? So combine and cancel out. And there's one additional thing, and that's to reduce if possible. Reduce the coefficients if possible. So your electrons should always cancel out in this step. You should have the same amount of electrons here, and that should basically always happen. So again, I'm just going to rewrite the equations again. 6 electrons plus a dichromate plus 14 H pluses goes to 2. Chromium 3 pluses plus 7 waters. And then on this other side, we have 6 iron 2s goes to 6 iron 3s and 6 electrons. So when we combine the equations, what you want to do is you want to combine the reactant side to the reactant side and the product side to the product side. So over here we have the reactants, over here we have the reactants, so we want to add those. And your electrons should always cancel out, right? So we have 6 electrons here, we have 6 electrons here, so we can go ahead and just cancel them out right away. So then we have this Cr2O72 minus plus 14H plus 6Fe2 plus. So there's our reactant side. And now we want to add our product side to our product side. So here we have 2 of these Cr3 pluses, 7 waters, and then 6 Fe3 pluses. We notice that we don't have the same of anything on either side, so we don't have any further canceling to do. And then we can reduce the coefficients if possible. Here we have a coefficient of 1, so we're not going to be able to reduce this any further. If you're not sure about what I mean by that, the next video will show an example of that. And so then the last thing to do is, of course, double check. So let's check our chromiums. On this side, we have 2. On this side, we have 2. Check our oxygens next. On this side, we have 7. On this side, we have 7. Check our hydrogens. On this side, we have 14. On this side, we have 7 times 2. That's also 14. And then finally, check out our irons. On this side, we have 6. And then on this side, we also have 6. And then the last thing you want to check is the charge, right? The charge needs to be the same on both of these. So over here on the left side, we have this 2 minus, we have plus 14, and then we have plus 2 times 6, which is 12, for a total of plus 24. Here we have 2 times 3, so that's plus 6. Here it's just 0, and then 6 times 3 is plus 18. Add those up, we get plus 24, right? So you notice that the charge is balanced as well. Note that the charge isn't 0 on either side, and that's because there's spectator ions about, right? So this isn't the full equation. We're just showing the components that are actually reacting in the reaction, right? There's some spectator ions to balance the charge and have 0 on either side. And so then we're done.